Oh, thank you, thank you. Hold your applause to the end, please. It'll take too much time for applauding the whole time. Oh, thank you. All right, trig functions. I know that you've heard of these things, trig functions. I'm going to break it down. What word do we see? Well, it's trigonometry, but what word or prefix do we notice?
Triangle.
Trig, triangle, right? This is just the math of triangles. I don't see tricycle, but it's the same root. You're right. All we're doing is we're learning some special functions, a special part of math that involves triangles. From this, just this large idea of trigonometry, we can find the angles for any right triangle. We can find the sides for any right triangle because there's a relationship between the sides and the angles. It's really kind of a basic idea. I think it's kind of mystified. People hear trig and they get a little intimidated, right? Quick question?
Is this the type of math that is like most widely disliked by people, or?
I think it's up there. We'll see. I'll let you guys be the judge. Honestly, I think there's more of an intimidation factor than an actual problem with doing the problems. Okay. It just hurts. Okay.
This is actually, super intimidating.
Okay, guys, so here's the deal. I know that's a perception, but let's give it a chance. Really, I'm going to also have these definitions up for you. But once you learn this word right here, everything will make sense. Okay, this is Sohcahtoa. That's right. We'll get there. Okay. A little bit of vocab review. Theta. Theta is an angle that we don't know. It looks like this. It's zero width, a line horizontally like that. Yeah.
So it would be like angle X.
Right.
We don't know X.
Right. But if we don't know, if it's not given like a variable, angle Z or angle Y or angle X, then if it's ambiguous, we don't know, we just call it theta.
Okay.
That's all there is to it. We already know Pythagorean theorem relates the different sides of a triangle. What is this special C value over here? What side is that called? What's that called?
Hypotenuse.
Hypotenuse. And where do you always find it? It's across from what? Across from the right angle, right? All right. All right. So to start, there is a lot to remember up here. If you could remember this one word, the rest of trig makes sense. Okay. Sohcahtoa. Sohcahtoa.
Sohcahtoa.
Sohcahtoa. Okay. We'll learn that because it's kind of hard to misspell that if you have that word down. So we know that there's an O, an H, an A, an H, and an O, and an A. And those are the sides of a triangle that we're going to relate right now. So here's the deal. If you look at, where am I? Right there. All right, let's see. If, let's say, this was my theta, okay? That's my theta. What would be the opposite side to that theta? What's the opposite side? A. What is the adjacent side next to? B. Because what is C always? C is always? Across from the right angle, so it's called? Hypotenuse. Okay? So, we'll wake it up. We'll wake it up. There we go. So if I have, let's say, an angle right here, it's a right triangle. Here's my theta. Let's identify and label first the opposite. What is the opposite to that angle? The opposite side is? Down here. Which is the hypotenuse? Hypotenuse. Which is the adjacent? The last one, right? You can always label the hypotenuse probably the quickest. You know that's across from the right angle. The first step, when we get to this, the step is to find C and then identify your opposite, your adjacent, your hypotenuse sides. That's what we got to do mainly. Okay, so let's look at this. We're going to remember our Sohcahtoa. We have three main trig functions. Three trig functions. We have their inverses, reciprocals, but we can remember these. The reciprocal is just switching the ratio. Now watch this. If we have the sine of theta, Sohcahtoa, right? Sine is opposite over hypotenuse, right? The word Sohcahtoa tells us how to set up our ratios. The ratios are most important. So the sine is opposite of hypotenuse. See, opposite of hypotenuse. Whatever the side lengths of those triangle, the side lengths of the triangles are going to go right here, and that's how it relates to the angle. Sohcahtoa, right? Sohcahtoa. Cosine is the next function. Cosine is equal to adjacent over hypotenuse. You see how the word Sohcahtoa has all the clues in it. All right. Next, T, sure. So Sohcahtoa, the letters actually tell you how to set up the ratios. So, right, this first part, sine is opposite over hypotenuse.
Oh.
Sohcahtoa, C is cosine. Cosine is the adjacent over hypotenuse. Sohcahtoa. Toa, T is the tangent. Toa, so it's opposite over adjacent. You see? If you can remember the word Sohcahtoa. So everybody say it to themselves or out loud. What do you say? Sohcahtoa.
Sohcahtoa.
Sohcahtoa. You can say that. Sohcahtoa.
I don't know about that.
Me neither. But whatever helps you remember. Thank you. So listen up, listen up. All right. So we have Sohcahtoa. That helps us find the identities. So let's just turn this over here. Let's a bit. There we go. All right. Here we go. I'm going to put a triangle. I want you in the notes, just on the border, wherever. Go ahead and draw this triangle real quick. We'll call this A, B, and C. We'll say that this is, let's just do a regular triangle here. 3, 4, 5. All right, if I'm trying to find the sine, let's say this is theta. First step is compared to theta, which is the hypotenuse. The hypotenuse is always the same, which is the hypotenuse. This is the longest one. It's across from what angle? Hypotenuse is across from? Right angle. So this is my hypotenuse. I'm going to label the three sides first. Hypotenuse compared to this angle, which is the opposite. What's the length of the opposite side? 4. So we are opposite. It's opposite. It's opposite of the angle, of the theta. Which side is adjacent to theta? Adjacent? All right, is that very hard to figure out which is which? Not so much, right? Always start with hypotenuse because that's always across from the right angle. From this theta, the opposite is always across. It's opposite. Adjacent kind of comes in last. Right? So we can figure those out pretty quick, right? We can figure out what is hypotenuse, opposite, and adjacent pretty quick. All right, so I'm going to let you have these 6 identities labeled out. I feel like once you memorize Sohcahtoa, you won't need it as much. But the only difference is these reciprocals, all the reciprocal functions, the cosecant is related to the sine because it's just the sine flipped. You see? The secant is related to the cosine because it's just the cosine flipped. Right? The cotangent is related to the tangent. It's just the tangent flip. Right? So really, if you know Sohcahtoa and you remember these 3, the others are just the opposites. All right. So this may all seem like a big concept still. Let's go up here and see, to find the trig ratio. So these trig ratios are like opposite over adjacent, adjacent over hypotenuse, opposite over hypotenuse. Those are our trig ratios. Now watch what we have to do. Find C. C is over here. We got to find the C. We got to identify the opposite, adjacent, and hypotenuse sides, and then we set up the ratios. So how can I find what C is right here? I know that the sides are 4, 3, and yeah. What do you say? Let's do it. Let's bring this over here. We have a squared plus b squared. So go ahead and fill this in. Equals c squared. We're going to go 3 squared plus 4 squared equals c squared. 9 plus 16 is 25. So c is 5. Square rooted. Got down to c pretty quick. All we did was, for example 1, we just figured out that c is equal to 5. Our steps are always to find C first, so we have all sides of the triangle. Yes?
So you find after you add like the 3 squared and 4 squared, then you get your answer. You just square root, and then that's your answer to C.
That's what it is. Right. It's that same process, right? We don't have to memorize the process. We know what to do at each step. So this was 9, that's going to be 16. So that's how I got 25, and then square root C is 5. So now this is, you've done a lot of the work already. Let's see. Next, identify the opposite, adjacent, and hypotenuse sides. Here's theta. Which is the hypotenuse? 5. Which is the opposite? 4. For sure? Got it?
Yeah.
The opposite is across from theta. It's over here. Opposite. Adjacent?
3.
Always do adjacent last because it's a little, you could mess that one up. But the opposite's kind of hard to mess up, right? It's across, it's opposite of theta. Hypotenuse is always hypotenuse. Okay. So now watch how this is going to go. For the first lesson here, 581, this is, what did I just do? 581 is just finding these ratios. That's all we got to do for the ratios. So you take one step at a time. Let's think of it as Sohcahtoa. Okay, so Sohcahtoa, sine is the S, right? So what goes on top? So, O over H, right? So I'm going to just put in these ratios, and then we'll just put in the actual numbers. Cosine, right? So cosine is what over what? Adjacent over hypotenuse. No problem, right? You see how the ratios are based on Sohcahtoa. When we get to the reciprocal functions, we're going to flip them. That's all. Tangent, Sohcahtoa.
Opposite over adjacent.
Opposite over adjacent. Okay, I want you to fill in those number values based on our triangle we were given. So what number values go in there? What number values go in there? It's okay if you make this a process. These steps right here work every time. Find C, we did that with Pythagorean. Identified hypotenuse, opposite, adjacent. Now we just set up our ratios. If you're confused, for the sine, I would look to see what's the opposite. I already labeled the opposite as 4. What is the hypotenuse? It's 5. So the sine of theta is equal to 5 over 4. Okay, so we're all doing these right here? You fill them in?
Yep.
All right, somebody help me out. How about the cosine of theta? What numbers, values am I going to put in based on this triangle? Okay, adjacent is 3. Hypotenuse is 5. How about tangent? What am I going to put here for?
4
over 3. All right, thumbs up, sideways, or down for putting in the ratios. Good so far, right? It's not so bad. Sohcahtoa, again, I'm going to say this as many times as I can. Sohcahtoa. Who can say that 10 times fast? Class fail. That's okay. No, that was good. No, that's a change. All right. I don't know where that came from. All right. So is it going to be any big deal if we have to find the cosecant? We know it's based on the sine. We know that the cosecant, where the sine is just
the reverse.
Reverse, aka, it's just the reciprocal. Okay. So if I'm going here with sine of theta, just turn it. Oh yeah. Remember. The sine of theta was 5 over 4, so what's the cosecant of theta? I said it backwards, didn't I?
Yeah.
The sine of theta is 4 over 5, so the cosecant is just the reciprocal of that 5 over 4. Ooh. Cosine of theta is 3 over 5. The secant of theta is 5 over 3. The tangent of theta is 4 over 3. The cotangent of theta? 3 over 4. No big deal, right? Now, first we want to set up our ratios based on the triangle. Based on the triangle. Next, we're going to either find, whoa, jinx, bless you. Next, we have to do the step of either find the sides ratio or theta, and this is going to be using our calculator. So I want everybody to get out the calculator that you're using. Who borrowed my calculator up here? Oh, there was another one up here. Where'd it go? Oranges. Thanks. Let's see. That's the not the one I wanted to use, but I guess I can. Thanks. Good suggestion. All right, so look on your calculator. If you're using your phone, you have to have the calculating turn it sideways so that it gets the other scientific functions. So everybody looking at their calculator. You guys have seen these buttons since you got this calculator. Now you know how to use them. We have sine, which and it says sin, but it's sine. That's what those are.
That's what we're learning.
Yeah.
Okay.
It says cos, C-O-S, cos, that's cosine. And tan, what's tan?
Tangent.
Tangent. I want you to look behind that, the second function, or maybe on your phone you might push second. And then instead of sine, what does it say?
Sin minus 1.
Sin minus 1. There's a joke in there somewhere. The joke is that there's no joke. All right, so you look behind the second functions. Instead of sine, it says sine to the -1. Instead of cosine, cosine to the -1. Tangent to the -1. Right? All right, that is how we're either going to find our side ratios, or we're going to find theta, based on what function we use. Okay. So here's how we're going to do this. I want everybody to go ahead and push sine, and then type in 40. The sine of 40 degrees. So different calculators will look different, but here is sine of 40 degrees, and we're going to go ahead and execute that. And what do we get?
40.
0.64.
0.643.
Wait.
Yeah.
0.64.
Mr. P.
Yeah.
I think I'm doing it. Well, I hit sine, right, and then I hit 40.
Okay, now push sine. So some calculators you have to put in the 40 first and then push sine. Some calculators you have to put sine and then 40. So figure out whichever calculator you're using right now. Figure out what gets you the 0.643. So here's the deal. Here's the deal. I'll give you a moment for that. Everybody try that. All right. So looking at that, let me refocus for those that need to see, like everybody. So before, what we did was, based on the triangle, right? Based on the triangle, we found the ratios, our trig ratios, right? What we've done here is, instead of having the sides given to us and we find the ratio, we're given the angle, and punching in the angle gives us the ratio of the sides. Okay? So if we're looking for the sides, if we're finding the sides given the angle, then we do the standard function sine. If we're looking for the angle, theta, given the sides, right, then what we do is that inverse function of that ratio. Okay. We'll do it a couple times. I think you'll see it's kind of clockwork once you start doing them. Okay. But go ahead and do this one now. I want you to go ahead and find what is theta. Right now, if you do the inverse of the side ratios, you're going to find some angle measurement. So we're going to get some angle measurement right here. So go ahead and punch in, either you're doing inverse sine and then 4 over 5, or you're doing 4 divided by 5 and then inverse sine. So I'm going to go ahead and just give a little demo on T83. So we're going to go second sine 4 divided by 5. Right? Let's close that parenthesis up. That's backwards because it was upside down. There we go. All right, we execute. We do that, right? And we get 53.1.
Yes.
Nice. So watch this. I want everybody to look at this now. If we have this triangle, what we basically had was, we knew we were doing with the sine. The sine is opposite over hypotenuse. So if this was our theta, we had 4 and 5. If you have two sides of a triangle, you can find theta every single time. That's what trig allows you to do. You actually will use this. I was, I'm going to get a dog in the next
Really?
month. Oh yeah.
What
So,
type?
Probably like Border Collie, Australian Shepherd.
Oh, yeah.
The ones you showed me Friday.
Maybe. Thank you. I'm getting a dog. Thank you.
All right.
Any names in mind?
Not yet. So I have to see what they're like.
Come on, 100.
I'm Hondo.
Yeah.
Hondo. That's a good name. Name competition, maybe. What I'm doing in my backyard is basically setting up my fences. I'm redoing some fences, and I had to do some angle measurements that use trig functions, and I got on my calculator and it totally worked. You absolutely can find the side length based on the angle, or you can find the angle based on the side lengths. Because how much you open it, the length of these sides, if this became longer than 4, if it became longer, that angle would have to open up further, right? The angles on sides are totally related. So what we just figured out when we were doing the inverse sine of 4 over 5, we have a triangle with theta, opposite over hypotenuse. So we found that this theta was 53.1 based on the side lengths. Okay. And that's what I did. I had to find this beam that I couldn't quite measure because it was too high. But I found the lengths. I found this side, and I found this side, because I could measure those, and then I was able to make this beam right here with the perfect angle, so that it fit perfectly against the wall. Okay, so this will come in handy. I've used this a bunch of times, and it's not that hard. Once you know Sohcahtoa, if you only remember Sohcahtoa, you could figure this stuff out again. You can remember it, how to figure it out after we do it a few times. All right, so I actually used to help a friend who, it's you guys know who Danny DeVito is, right? Yeah. So,
No.
Danny DeVito? Crickets. He's on It's Always Sunny in Philadelphia. Or,
Oh yeah.
you know the guy who's short?
Oh yeah.
He was in Twins with Arnold Schwarzenegger. Oh.
Okay. I love that guy.
So anyway, his nephew, his name's Nick. Nick's my friend. So he lives in Pasadena. He's an amazing artist. He does the like when there's like a horror movie with the actual like gore and all the like artwork. He does that like professionally. He gets paid really well and everything. So I've helped him a few times make sets for movies. And one time I had this set. Basically, he had already constructed one of the walls, and it was a set where the side walls were forced perspective. So it was angled in a way that when you have both walls here, it looks like it's really far. So he had built the left side of the wall already, and I had to build the right side of the wall. Or no, he had sketched it out, or something like that. Basically, using trigonometry, I was able to build this like 50-foot long wall, knowing this length and knowing this length. Because that allowed me to get this theta, the angle, and then I could cut everything to that perfect angle. So knowing trig, I was helping him for free because it was just fun. But if you can pull this trick out and actually use it, for the rest of your life, you'll impress people. If you're building a doghouse in your backyard and like, let me get out my scientific calculator, right? It's a trick that actually you can use instead of having to guess. Okay, it's really cool when it works out. When the angle fits perfect, you're like, oh, I love math. What's up? No, I'm pointing at you. You asked the question. What's up?
Oh yeah. So everything in math is puzzles.
You can think of it that way.
Like puzzles, like you just log things in, and then you get the data that you need, so it's not thing.
That's right. You can think of it that way. It's like a utility. It's a utility. So think of it that way. And not everything in math, you're going to apply. But actually, I think this is one. I've used this at like critical times on a few occasions, and it's been really helpful. So this week, we're going to get some tricks to work this stuff out in clever ways. Basically, it's just making us more clever. Think of it that way. All right, let's do these example problems, and I think it's going to click after we do these example problems. Let's see. Is that? It's kind of visible. Let's close this a little bit. Maybe. Okay, we need to find the angle measurement of x. We have these sides. So first off, we need to find c. Let's find c. So go ahead and find c. We know c squared is equal to these, right? It's squared and added. So what is c in that case? 100. C squared is 100. So c is... Wow. Don't be surprised. Jordan knows quite a bit. He's going to sub for me one day. Good. 10?
Yeah.
C is 10, right?
Yeah, we did that earlier.
Very good. C is 10. Okay. Here is your theta. I want you to, here's theta, the x degrees. I want you to label your hypotenuse, opposite, and adjacent. Once you have those down, we're ready for our ratios. We're ready to solve this. And where's the hypotenuse always? Yeah, this is a right triangle. I forgot that one there. Hypotenuse. Here's theta. So which is opposite to theta? 8. Opposite. Last. Adjacent. Next to. Okay. So we have our 3 sides here already labeled. Now, we can use any of our trig functions to find theta. So which one should I use here? Which one should I set up? What's your favorite so far? Sohcahtoa. Sohcahtoa. Which should we use? Yeah, because we have all the sides. We're not forced to use any of our tangent. Oh, excuse me.
Sin.
Sin?
But I don't like
You don't like to sin?
Ah.
What do you want to use now?
Oh, you need sin.
Oh, okay. Like I do. All right, so watch this. Watch what I do. Sine of theta. That's this. What is the sine equal to? Opposite. Sohcahtoa. So opposite hypotenuse. So I'm going to go ahead and take the opposite 8. I'm going to put the hypotenuse on the bottom 10. So we get. Sorry, there should be an equal sign between those. The sine of theta is equal to. Good. So we make that into a decimal just to make it a little more simplified. Yes. Is there? Michael, could you pull that curtain like 5 feet towards the front? There it is. All right. So watch this. The sine of theta is equal to 0.8. Just made that into a decimal. Now watch this. Let's look to see. Are we interested to find the side ratio here or to find theta? Are we finding the angle or the side ratio? What's missing here? We don't know the angle. We're trying to find it. Right? So let's look to see. Finding the side ratio given the angle, we would use this. But look, we're finding the angle given the sides. So which function are we going to use? Are we going to use sine or the inverse sine? What do you think? Well, let's see. If we are looking for the sides given the angle, then we use regular sine. But if we're looking for the angle given the sides, then we use the inverse. We're going to use the inverse. So I look here, and what's missing? I don't know what theta is. So watch what I'm going to do. Theta is equal to this inverse sine of 0.8. If Let's do that one. Let's do that one. So practice on your calculator. We're going to go ahead and put inverse of sine times 0.8. Theta is. Okay, so it is the same problem, but we just had to approach it different. It's exactly the same. That's all right. All right. All right, this problem is really similar, so what I'm going to do instead is I'm just going to change it up slightly. Let's change this one up. I want to look for something different. I'm going to give you this is 8 and this is 15 and that's our theta. I want us to find actually just kidding. Let's make this 30 degrees and we'll make that side x. So now right off the bat, what am I looking for? Am I looking for the angle or am I looking for side? Side. So because I'm looking for the side and I'm given the angle, I know I'm going to be using just the regular function, not the inverse. Okay. So now watch this. I know that this is my theta. What sides? Let's identify our sides first. Which is the hypotenuse? Hypotenuse. What is the opposite? Opposite. What is the adjacent? Okay. What sides are involved in this problem? What information do I have? I have information on 2 of the sides. Which ones? Opposite and adjacent. I'm looking for x, so that is something I'm looking for. I have some information on it. I know I'm looking for it. What trig function should I use if I have opposite and adjacent involved? Sohcahtoa, opposite and adjacent. So watch this. I'm going to go ahead and do the tangent of 30 degrees is equal to the opposite over the adjacent. Okay. This is the key. That's how we're setting it up. You look to see, compared to the angle, what is hypotenuse, opposite, adjacent, and then look to see what sides are involved. And that's the trig function I'm going to choose. It was opposite and adjacent, so that's why I chose tangent. Okay. Now watch. Tangent of 30 is equal to square root of 3 over 4.
I got the third word for 3 over 3.
3 over 3. Oh, okay. So it's 1 over root 3. Okay, so what?
I did it wrong.
Give me a decimal. You're right.
0.57.
0.57 what? So 0.58 is fine for me. X over 15. Watch this. Now, you could do that. Cross multiply. X is whatever this is times 5, 26, 50, 60, 64, 84, 8.4. That'd be awesome. Dang it. So we just found that this side is 8.7. So this is the first day I'm introducing a lot. Every day that follows, we're going to be doing the same kind of things, just applying it different. Okay, so if it doesn't click right off the bat, that's okay. We'll do it. Anyone want to see another one kind of like this? All right, how are we feeling? Thumbs up, sideways, or down? I'm guessing a lot of sideways and some ups. Okay, I want to do one more problem then, just for fun. Okay, this one's for you. We know this is 40. We have this is 12, and we have this is 7. All right, I want you. We'll have that as x. I want you to find x. So first off, compared to the angle, in relation to the angle, what are the hypotenuse, the opposite, and the adjacent? Same process. Hypotenuse, opposite, adjacent. Remember, it's in relation to that angle. Opposite is always across from it. Hypotenuse is always the same. Adjacent is left. So, let's see. Think of Sohcahtoa. Sohcahtoa. First off, what sides are involved? Opposite and hypotenuse. So, which one should we use? Sohcahtoa. So, let's use sine. Although it does read sin. You're right. Sine of 40 degrees is equal to opposite over hypotenuse. Okay. Everybody do first the sine of 40 degrees on your calculator. Let's do that out. Get sine of 40. 0.643 because you round up. 7 over x. Throw that over 1. Cross multiply, we get 0.643x is equal to 7. Last step. Okay. Say it again, please. 5.64. No? Is that right? 0.643 times 7?
When you divide it, because you're trying to...
Oh. You divide it, so it's going to be like 4 point something. Thank you. I need to go get some more candy because I'm making end of the year mistakes. All right, 7 divided by that number. 7 divided.
0, 9.
Yeah.
10.87.
Yeah.
10.89.
Yeah, 10.89.
Let's do it again. Do it again, Blake. 7 divided by 0.643.
I did 6.43.
Yeah.
Because you do it like 1 over, yeah, it would be 10 point,
There we go.
10.89.
All right. Okay, I want it always rounded to the hundredths place here so that it's just like money, just think of it that way. Okay, so first step, identify hypotenuse opposite adjacent compared to the angle. Decide what ratio you want to use. Set it up, solve for x. Okay. Is that enough, do you think? Want to try this now? A little bit of that? Okay, go ahead, set up the ratios. The first part is setting the ratios. Second part is solving them like this. Yeah, it is all on the iMath too.
I'm having trouble with the calculator.
Okay, let me remind those. 123rd, get some Oreos. I'm at 103. 20 to go. All right.